Hey guys, so in this video we're going to talk about Pascal's law and its most important application in physics, which is the hydraulic lift. Let's check it out. Alright, so Pascal's law states, and you should probably memorize this, that pressure in a confined fluid is transmitted equally throughout the fluid. So what does that mean? That means that, let's say you have a contraption like this, and I apply a little bit of pressure here, P. Well, that pressure is going to be transmitted equally throughout the fluid. Now, what does that mean in terms of problem solving? Not much. So let's not get too hung up on that definition. I just want you to memorize this in case you need it. I have other definitions that I think are going to be more useful in problem solving. A second related rule, it isn't like a law named after anyone, but you should know that pressure in the liquid. So do you think pressure in a liquid does depend on the shape of the container, or do you think it does not depend on the shape of the container? So for example, is the pressure here at this point the same as the pressure here, or is it different? And the answer is that the pressure is actually the same. The pressure, you should know, does not depend on the shape of the container. It only depends on some other stuff. If you remember, P bottom equals P top plus rho g h, and h is depth. So pressure at the bottom over here only depends on the pressure at the top. It only depends on the density of the liquid, on gravity, and on depth, right? So if you have air up here, then air is pushing down on all of these just the same, with the same amount of pressure. So pressure at the top, therefore, is the same. If you have the same liquid everywhere, density is the same. Gravity is going to be the same for all of them because they're all sitting next to each other. And if the height, so with all these things being the same, if the depth of them is the same, then the pressure will be the same. So I can actually say that the pressure at all of these points here is the same. So all other things being equal, pressure depends only on depth. So I can say all things being equal, pressure is proportional to depth. Okay. Now remember that depth is top down. Depth is top down. Okay, it does not depend on height. It's not measured from here, because then these two guys would have different amounts of height. See how the two blue lines have different lengths, right? So this is higher point than this point. It has to do with depth. So you measure it from the top down, and if the depth is the same and all of the other things are the same, then the pressure in this line is going to be the same. So all of these, all four pressures at these 4 points are the same. Cool. So that's what point 2 was referring to. Point 3 is referring to this image over here, and it says in connected columns. So if you have something like this, some weird contraption that has connected columns with liquids inside, the liquid height, this level up here, is going to be the same as long as the pressure at the top is the same. So let's say, for example, you have air up here, right? Then that means that air is going to equally push on all of these, but it could also be a different gas that's not air. It's going to equally push on all of these, and it's going to basically balance out those heights. If I were to add a little bit of liquid, let's say we add liquid here, add liquid, then the additional liquid is going to be spread out in such a way that the heights are the same. That does mean that most of the liquid is going to end up on that fat column, but that's because they have to balance itself out. One sort of way to remember this is, you might have heard this phrase, water seeks its own level. It just means it's going to balance itself out. So you should know these 3 rules. They will be helpful throughout the rest. So now let's talk about the hydraulic lift, which is the most important application of Pascal's law. And the hydraulic lift has this rule here that I will talk about in just a bit, but let me first explain how it works. So the first thing is a Pascal lift, hydraulic lift is going to be built out of 2 columns of liquid that have different sizes, right? So you can imagine these are usually going to be cylindrical columns, so they kind of look like this, right? It's like a tube, cylindrical tube on that side. So